So, methods. Methods or functions are, of course, not a C sharp specific thing. They apply to all programming languages. Actually, functions are a math thing. So you get something like this. Okay, this is a function in mathematics. But since this is a C sharp channel and video, we will of course be concentrating on methods with respect to the C sharp programming language. So, what is a method? Simple. A method or function is a named code block that performs a specific task when called. So, here. So you have something like this. Um, class vehicle. Now remember, methods in C sharp is an object oriented programming language, which means that everything is scoped to an object, which is either a class, a struct, or an interface. And so I think I talked about that in previous video. So anyway, let's imagine an object called vehicle, and then we say what would be a method inside this. We could say start engine, and then we say method statements go here. Okay, so this would be a method, and the statements, whatever this executes, the method statement will go here. Now, speaking of object-oriented programming language, so in object-oriented programming, in object-oriented programming, an object is an instance of a class that encapsulates data, and that data is of course called fields or properties, as well as behavior. So here we would say something like public string model. So the model gets set. This would be an example of data. Okay, so an object is an instance of a class that encapsulates data, which comes in form of fields and properties, as well as behavior, which would be something like start engine. Okay, um, it may take inputs which are then processed. Methods may or may not return an output. So we could say, let's not worry about this, for example. Um, and you can have multiple methods scoped to a single object. So we could say, when we say we may get an we may put in an input. It may take inputs. So we could say add gas, for example, and we say int gallons of gasoline. Okay, so once again, just like before, okay, we would have to take this int gallon and do something with it here, but this would be an input. The primary purpose, and also we may create a method that gives us a return value. Okay, we don't have any right here, but the primary purpose of a method is reusability and readability. If you want to call, let's say, add gas method, you don't need to write a new algorithm for each vehicle. You can just write it once, then call it anytime you need it. An important characteristics to consider is that C sharp methods are not standalone entities. Like I said, they must, let's reduce this a little. They must be defined within the scope of a class or struct or interface. Okay? So you could say class my class. You could say structs my structs. You could say interface I my interface. So if you say, so let's create a method. For example, you say my method, and we see this gives us an error. We can see that if you say top level statement must precede namespace. But this is about this not being scoped to anything. So for example, if we take this and we say, and we move it into this, you see that error is gone. If we move it into an interface, that error is gone. If we move it into a struct, that error is gone. And if we move it into a class, that error is gone. And that's my point. Now, the reason why you must scope everything, even fields, property fields, like uh, when I wrote model, for example, it has to be scoped to one of these. Okay, this is a deliberate design choice by the creators of C Sharp, and it lies at the very heart of object oriented programming. I will talk in depth on OOP as it relates to C Sharp in the future, but for now, let's keep going. So even this right here, console.writeLine, console.writeLine with the hello world, you see when you start a C Sharp console application, this is actually syntactic sugar called top level statements. Okay, in reality, when you run this, the compiler replaces this because this is actually a class. Console is a class, and write method is it's WriteLine is a method. When you run this in C sharp, what you're actually getting is this. When you compile this, you will get this internal class program, and then you get private static void main string args um, console dot write line, and it says hello world. This right here, this is what you get if we were to comment that out. This is the full thing. And in fact, if you go and look back in old C sharp tutorials, when you create a console application, this is what you get. Okay? They just replaced this with this for convenience. So you can just run one line. But when you do run the application, behind the scene, the compiler replaces this with this. Okay? So, like I say, console is actually a class and WriteLine is a method. So, let's look at let's delete this. Let's look at the syntax of a C sharp function using a nice example. So we say class math, okay? And we say public int add int a as an input and int b. Now, this is obviously self-explanatory. We're creating an inside a class called math. We're creating a method meant to add two integers, and so we have to say return a plus b. Okay. All right. So this is what it looks like. This is a full method. The word public over here is an access modifier. Int here is the return type, and an add is the method name, and int a and int b are parameters. Okay, so access modifiers, this public here, access modifiers control the visibility of the method. Okay, there are four access modifiers that are known. Public, which is here, which means that method is accessible from anywhere. So you can call this method from anywhere. So we can say, actually, we would, in order to call, no, in order to call this, we would also need to make this public. So we could say, let me see if I can do this. Uh, math, sorry, math equals we say new math, and then we can say math dot add 5 plus 2, whatever that is. Okay, and so obviously this will give you 7, you know, but you could say int x equals math.add, and if we run this here, we can say, let's see if this actually works. .NET run, and we get 7 as expected. Okay, the reason we can call this is because this both the method and the class are both public. Now if we were to take away either one of the, let's take away both. Okay, public, public, and we can see right away, well, let's put this back. But when we took away the public, we see math.add is inaccessible due to its protection level. Okay, we cannot call this. The only way to use this is to put back, make it public, like this, and then everything is happy. The compiler is happy. Okay, now, so that's public. The next is private. Private just means inaccessible. Private means method can only be accessed only within the class. So let's say there's another method here. You can have multiple, you obviously know you can have multiple methods inside one class. So only another method within this class will be able to access this add. Okay, so it will give you an error as well, because this is private and it's only accessible within this class here that I've highlighted. Okay, here's a fun fact. Methods and classes like this are scoped to be private by default, which means that if writing private and not writing anything at all is the exact same, will give you the exact same outcome. These are both private. You understand? So when you don't specify which access modifier you want, then it's automatically private. Okay, private is the default. Next up is protected. Protected, it means that it's accessible within the class and derived classes. In other words, if another class inherited from the class math, let's say sub method, okay, then that class would be able to use this method as well. Okay, so they would have access to add method. Now, um, I don't want to go too deep into it, but let's run it through because this is for a future more complex video on object oriented programming and inheritance and all the rest of them. And the next one is internal. Okay, internal means that the method is only accessible within the same assembly. I should have. That's not what I meant to do. We're not doing. We're talking about the method. Internal. Okay. So as you can see here, it works. Okay, but that's because this is within the same assembly. What does the same assembly mean? Well, you see this CS proj. Every time you create a class library, then that's an assembly. So I can call it within the same assembly. This ch proj here classifies everything within here as the same assembly. Whenever you create a new project, it's called a class library. It comes with a csproj file. So if I'm trying to limit the access to different when you build an application, there are different layers, and so you want to protect the access to some, especially like sensitive things, also not to cause clashes within the project naming conventions as well. Okay, so two things to remember. First, access modifiers aren't just about methods, they also apply to classes. So as we can see here, this class here has a public as well, and all those public, private, protected, internal also apply uh, uh, to the classes that encapsulates the methods. Okay. Secondly, when you don't specify, like I think I already said this, when you don't specify an access modifier, it defaults private. So if we took away anything here, then it's automatically private. Okay. Next up, let's look at the return type. All right, return type. Let's put this back to public. Okay, return type. Return type specifies the type of value the method returns. Okay, now when looking at our math functions, we can see that adding two whole numbers, integer and integer, will return another whole number. So which is return a plus b. Actually, let's simplify this. Okay, let's remove this and say and c equals a plus b, and then we return c. Okay, so this helps clarify things for new programmers. If you're new to programming, that's the same thing as saying return a plus b. All right. Now we may need to return processed data for various reasons. Could be to save in a database, and this is important for real world applications. Like I said, to save in a database, to display to users, or even further processing. So let's look at an example Okay, because we're not just returning integers, we can return all types of values, all types of data. So we say public class greetings, and we say public string get greetings, string name. Okay, and we say return hello and name, like this. All right, now, so what we're returning here is a string, and here we say greetings, greet, new greetings. Okay, and then we can say um, over here greet dot get greetings, and let's say our person is David. All right, now we say .NET run, and we say hello David. And this is just a simple example. Here's something very important and useful in the real world that you should know. So this is just to demonstrate it's not just like integers. You can bring strings as well. You can return strings as well. Here's what you need, a very important and useful in the real world. The return type can actually be a custom type, which is a class, a struct, a record. Let's also demonstrate that. We've demonstrated integers, we've demonstrated strings. Let's do something a lot more useful in the real world. Okay, so we say um, imagine it's a game, public class player. Okay, and then we say public. Let's call it the person's name. Get set. We say the person's score. Remember, we're making a game. Now we can public player string name and score. And then we can say name equal, we'll put it as name, and score we'll put it at score. Okay. Um. Now let's go ahead and return a player rather than strings or integers. Let's return a custom object called player. So we say class program static void main. I wish I didn't delete that the first time I wrote it, but this is why. Player new player create. Actually, let's go ahead and create the method static player. This is the return method when we create a player. Okay, then we say what do we need to create a player? We need two things to create a player: a string and a score. Okay, hopefully this is not too much and overwhelming if you're uh, new to programming, but if you're already used to programming, then this shouldn't be a problem for you. And we say new name and score. Okay, so now we can see we've created this method here called create player, and our return type is in fact a player. So we can say create player Frank 120. This is of course console dot write line uh, name and new player dot name as well as comma score new player dot score. Okay, I know this is a long example, but I'm trying to demonstrate that useful applications is not just, and if we run this, let's see if it returns. Okay, so we've created a new player called Frank, and he has a score of 120. And so this is the real point here. We can create methods with um, custom return types, not just integers or strings, but actual objects. Okay, so when you add together a name and a score, you turn it into an object, and you called player, and you return that player. Return new player name score, just like that. Now we've talked about returning integer strings and even class types, like we've seen here. But if you're not returning, now this is important. If you're not returning anything, whatsoever, then use void. Okay, use void. Okay, console dot write Okay, so if you're not returning anything, then use void. Like when I created the car, what did I call it? Okay, class vehicle. All right, and I returned a method called void. Remember that? Um, what did I call it again? Uh, Man, I'm going back in my brain. Um, vehicle. Right. Start engine. Remember that? We start the engine of this vehicle because void here. We're not returning anything, so you use void. When you're expecting a return, that's when you put something different, but with no return, you just bring in void. Okay? If you're not expecting anything to be returned in your method. All right. So, let's talk about parameter. Okay? When I said, oh man, I wish I didn't delete that, but when I said static player, oh good lord, ignore the errors for a second. But when I said string name int score and so on, and I said return new player name and score. Okay, here two parameters are required. Okay, two parameters are required: name, which is a string, and then int, which we call score. Parameters. Okay, parameters are arguments that are passed into methods, which are then processed. Okay, we pass this a name and a score, and it processes it and turn it into an object called player. Remember, this is, but that's because we deleted our player, so that's why we're getting this error. Okay, by default, parameters are value parameters. This means that arguments are copied into the method without affecting the original variable. So if you create string name and int score outside of this, it would simply copy it without touching the OG, the original. So here, let me go ahead and do something. Let me show you what I mean. Okay, so when you say something like void increment, and we say int num, right? And we say num plus plus console dot write line incremented num. Okay, so we just created a method here. Now if we were to say int value equal 5, increment value. So what does this mean? Plus plus means 1, right? 5 plus 1. This method just takes whatever number you put in here and increases it by 1. Whatever whole number. It has to be an integer. It has to match. Okay, so when we come out, you say console, and we say and right, this is important for you to understand this. We only copied this number when we put it here. We didn't actually change it. Okay, which is why when we do this, let's clear this, and we say .NET run, we get the incremented number we see here is, after adding 1, we see 6, which is correct. But if we come down here and we say original value, which is this value here, we see that it's 5. And that's the point, okay? It's value. Value parameters are good when you're working with small data type, int, bool, when you don't need to modify the original variable. We just simply copied this here. Okay, without touching it. We just say value 5. And we just put in 5 here without modifying or meddling with the original int value, which is assigned the number 5. Okay, so when you don't need to modify the original variable. This ensures encapsulation and prevents unintended side effects. Once again, this is already how methods work by default. Okay, you don't modify, you don't meddle with the original variable that is added. Now, on the other hand, we have reference parameter. So this is called value parameter. This here is called value parameter. But we have reference parameters. Reference parameters are arguments that are passed by reference. Okay, which means changes in the method affects the original variable. So all we have to do here really is just say reference. Let's rename this reference. Increment reference. Okay? And so now we have to put reference here, the keyword reference. All we have to do is put in the keyword reference here, and let's do that again. Int value, and here obviously we have to use reference as well. Okay, let's go ahead and try that again. So on the value type, the default of methods, the original variable assigned is not changed. Let's see, now that we're not using value types but reference types, let's go ahead and run it. Okay, and we see this is very different. Incremented by 1, which turns it to 6. But unlike the default behavior, it says original is 6. So not only have we changed this, this method has also gone back into this reference method has gone back into this object, this integer object, and changed it as well. So now it's gone back to 6. They're both 6. Okay? You should use reference parameters when passing large structs. When you don't want two-way data modification, when you do want two-way data modification, that would have been so confusing if I had not noticed that mistake. That was when you want two-way data modification, when you want to avoid copying large data for performance cases. And one more thing, the data must be initialized before being passed as a reference parameter. Okay, so next up, let's talk about output parameters. Output parameters are parameters that are used to return values from a method. They are similar to ref, except the argument doesn't need initialization. Remember, I just said reference needs initialization. Outputs don't. Output is denoted by the keyword out. So let's go ahead and see this in action. So we say void divide int a int b. So we're dividing a by b, and when we say out in results and out in remainder. Okay, so if it's not if it's not even, so we say result equal a divided by b, and remainder equals a small letter a modulus b. Okay, this is modulus remainder when it's not a perfect division. Okay, and so now we can say divide what wouldn't be perfect? Okay, 10 divided by 3. Then we say out int results, just call it results, and out in remainder. All right, so we can say here result. Oh, we didn't fully write results, comma remainder. And we say yes. 10 divided by 3 is in fact 3. Remainder 1, because 10 divided by 9 divided by 3 is, it's a perfect division. Remainder 1. which is why this is 10 divided by 3 is 3 remainder 1. And we can see here 3 remainder 1. Now, when should you use this out keyword, this out right here? Okay, when we are returning multiple values, and we can see here we did return multiple values, result and remainder, more than just one value. Okay, another thing is when you are trying to parse methods. So for example, something like try parse. Okay, this method right here. So when you're trying to parse try parse methods, okay, it's good to use an out. And also, for one thing, out clearly signals the parameter is output only. Okay, this is not a parameter that you would put in. This is just out. And it also kind of helps with the word out. Okay, this enforces assignments in the method as well. All right, so the opposite of out is in. Okay, and so the in parameters, the in parameter passes a read-only reference. This prevents modification inside the method, denoted of course, and it's also denoted of course by the in keyword. So we have something like struct. Let's use a struct. Point. We say public int x y. Okay. By the way, this is a shorthand way of I can say int x, and but if we put it on the same line, then as long as don't worry about it. But this is the same. This is the same thing as saying uh, public int y. Okay, let's just leave it like this. Okay, if you're new to programming, I don't want to confuse you so much. So we say point pt new point. Let's create a new point object, struct object. We say x is y, y is 10, and then we can say actually let's come out here and say void. Okay, we're not returning anything. Print points. Okay, and now when we want to prevent modification inside the method, we say in point p. We can call it whatever we want, but just p is just short form. We say console.write line p dot x p dot y. Okay, now we can come here and we say print points in pt. So we're passing in an entire struct. This entire struct, we're going to print it out. This should not be. Okay, let's clear screen. .NET run, and it says 510, 510, 510. Simple enough. So when should we use this keyword in? All right, you want to use input parameters. You want to use the keyword in when passing in large structs. Okay, so this, what we've done here is we've passed in this entire object just to be printed out. Okay, when you want to pass in large structs, read-only structs, okay, ensuring immutability for safety. That's what it is. That's what you don't want to, if you want to pass an object through a method without changing it. So here, let me give you an example. If I was to say p dot x, okay, now I'm trying to change this x variable, and I say, uh, Christ, and I say 12, for example, we get an error. And if you hover over it, it says cannot assign to a member of variable p or use it as a right hand side of, because it is read only, because it is a read only variable. Okay, that's what's going on here. It is a read only variable. That's it. You are not to change anything in it. The moment you use the in keyword right here, it turns it into a read only. So that's the point. Finally, you get a performance boost because you're avoiding uh, data manipulation. In short, use in when you want to guarantee the value doesn't change. Okay, that's it. Next up, let's look at the params array. And so we say int some params int, int numbers, and we say return numbers dot sum. That's it. And then we say console dot write line and sum 1, 2, 3, and of course summing them up will give you 6 right here, because 1 plus 2 plus 3 will give you 6. This is 3 plus 3 6. Okay, params obviously stands for parameter, s, plural. It is a variable length argument, which allows a various number of arguments as an array. And we can see that here the argument is an integer array. Okay, so use params when accepting unknown dynamic number of arguments. Okay, you should also use it when you want to simplify calls by avoiding manual array creation. It gives you a flexible and concise syntax, meaning it reduces boilerplate code. And finally, let's talk about optional parameters. Optional parameters. Optional parameters are parameters with default values. Colors can omit them. So we have void greet, string name, and string greeting equal hello. Console dot write line greeting name. And so we can come down here and we say greet Alice, and if we run this, it says hello Alice. Because we didn't assign anything to greeting, it gives us the default. Okay, and now we can say And if we do not, so we say Bob over here, and we say hi. So now we've given the greetings over here. It should overwrite the default greetings, and if we do, uh, and if we do run it, it should say hello, hi, Bob. Okay, if we don't give it any parameter, it defaults to this, and if we give it a parameter, it overrules the default. Okay, now optional parameters are good when you need to provide sensible defaults, like this is a sensible default, and reduce overloads for convenience. When you want to also simplify API usage, the default makes things clear and easy. It avoids redundant method overloads. I'll talk about that soon, what method overloads are. And now, this is very important. Listen very carefully. Optional parameters must appear after required parameters. So, this string over here, you cannot put it here. You cannot create optional parameters and say something like int age 5, for example. We get an enormous error. It says optional parameter must appear after all required parameters. That's what I mean. Okay? It must come after required parameters. Okay? And so, and we're done. We're done with method parameters. So, just to recap on parameters, we use value parameters for primitive types unless modification is needed, which is the default, of course. Use outs for methods that need to return multiple values, and also avoid using ref and out with reference types. Mutation is complicated, so if you're unable to keep track of your mutations, remember ref mutates the original value. Remember when we used ref? So apply in for large structs to optimize performance. And params, while convenient, can be bad when overused. Performance takes a hit for array allocation and reallocation and resizing of array. Essentially, what params does, okay, it's it helps you to create arrays that can grow and shrink as needed. So don't use it so much. Next up, let's talk about types of methods, which is this. Wow, I can't believe we've only been talking about structure and syntax all this time. Let's talk about types of methods. Okay, there are two types of methods: instance methods and static methods. Let's go ahead and start with obviously instance methods. Instance methods operate on a specific instance of a class. By instance, I mean objects. To break down all those big words, instance methods just means that it belongs to each individual object of a class or struct. So let's go ahead and do uh, public uh, class bank account, for example. Uh, Public double balance. Okay, this is an instance field. So let's create a public void deposit, because that's something you do. In a bank account, you can deposit money. And when you say underscore balance, how do you add money? You say, well, you say balance will be equals to whatever you had before, balance plus the amounts that you put in, right? Whatever amount of money you had before plus whatever amount of money you put in. And that makes sense. Each time, and so for example, so if we want to use this, we say bank accounts, we call this accounts equal new bank accounts. And we say accounts dot deposits 100, just 100. So we can say console dot write line. We can say console dot write if we want. Um, we can then say uh, accounts dot balance. Okay, and where is our command prompt? Okay, so we say .NET run, and we see $100 right here. Okay, because we started, of course, when you create a new bank account, it gets zeroed out. And so we added $100. So 0 plus 100 is 100. And that's, easy and intuitive for anyone to understand. Each time an object is created from a class, that method belongs to that new instance. In other words, anytime you see the keyword new like this, okay, the method deposit belongs exclusively to that instance instance account, okay, that object account. So this method belongs exclusively to this which is assigned here. Okay, that's all it is. You can call a method using the dot operator, as we see here, account dot deposit. Using the dot operator on the object, you can access fields and properties, of course, like balance, also with the dot accessor. It also supports polymorphism. I'll talk more about that when we get to object-oriented programming. So this is a typical example of instance method. Now, one thing you would use to know instance method is this new keyword, okay? Because this new means we're creating a bank account. We're creating this from scratch, okay? We're creating this on the heap. That's what this new mean. New is exactly what it sounds like, a new account called account here. Okay. Next up, static methods. Static methods, on the other hand, are very different. In static methods, the methods belong to the class itself, not to any object. Okay, so let's say public. I'm tired of seeing all these errors. So we say public class math helper. Okay, and we say public static int multiply int a int b return a times b. Simple enough to understand. Okay, so this static here, remember this, the modifiers that we put on our methods can also be put on the object itself, so the class. Now if we say int results equals, we don't say new. If we say new math helper, we get an enormous error. Look, cannot create an instance of a static class. This is very, very important. Math helper dot multiply. 5, oh, ooh, 5, 6. All right. Console dot write line, and we say results. Did you notice we didn't use the new keyword because we're not creating an instance? And if we say .NET run, we see 30. 5 times 6 is 30, and it works perfectly. Okay. Here you can see, like I said, we don't use the new keyword here. In fact, if you put in new, it's going to throw an enormous error. Okay, that is because the method doesn't rely on instance data. You also cannot access instance members directly. So if we were to create instance methods here called int something, um, something, we would not be able to use that. We have to make them static as well, as you can see, because this is a static method, static class. Without the static, it won't work. We'll get an error. All right. So um, it is very useful for utility or helper functions, something that is globally required or shared in a project. So choose static methods when the behavior of the class and methods are independent of objects. Only a single copy of a static method exists in memory. Static method and objects, okay, exist in memory at the type level, regardless of how many objects of the class are created. This is ideal for things like application settings, things that you need to only set up once, connection strings, and other configuration for your application. Okay? Um, let's talk about abstract methods. Abstract methods are declared in abstract classes. Okay? So the reason I'm reluctant to to go into this is because this has a lot to do with um, object-oriented programming. So abs- public abstract double get area. So for example, and then inherited from when you inherit from shape, and you can use this method as well. And we say um, public override double get area, and it implements it for us. Um, Obviously, this is not what we want. The area, of course, is going to be math.py times radius times radius for pi r square is the area of a circle. I know you know that. So this is pi times r, and r is r squared. Okay. This is obviously tethered to inheritance. Okay, abstract is about inheritance. For one thing, you must implement abstract methods. Okay, so you cannot leave abstract. You must implement it. If we don't implement this, in fact, as we did it, you saw it automatically implemented itself. It implemented. It didn't give us what we wanted, but it just showed that it had to be implemented. Okay. Um, you must implement it in class that are inherited from abstract methods. So if I were to remove um, this, for example, we get an error immediately. We see, and if we hover here, it says Circle does not implement inherited abstract method get area shape.get area. So you must implement that like this. Now that's not what we want, but you get the idea. Um, this enforces a contract for subclasses. You must override the method. This is called polymorphism. Also, you cannot implement the method in the abstract class. So if we come out here and we try to do something here and say uh, we try to implement anything here, it's going to uh, 5. Let's say it doesn't matter. It says shape dot area cannot declare a body because it is marked as abstract. So you cannot do anything with it. You can only declare it in the abstract class. You can't actually implement it. It's illegal to do that. Your code, the compiler will never agree to such a thing. And then next up, let's talk about virtual methods. Virtual methods are kind of like abstract methods, but they are key differences. First, unlike abstract methods, we can have base implementations. So let's go ahead and say, um, let's change this to uh, animal. I like to do things different. And then we say uh, public virtual void speak. Now, in the base class, we can, in fact, implement this. And we say console dot write line animal speaks. We just leave it like that. And when we inherit from, let's say it's a dog, and we inherit, of course, from animal, not shape. Okay, um, we can still override it. Okay, override void speak. And we say uh, console dot write line uh, dogs bark. Okay, so fair enough. And we can see if we do .NET Run, it should say dogs bark. No. We didn't. We didn't write, but you get the idea. We didn't actually uh, uh, implement this. Like we have to come here and say console dot dog dot speak. I don't want to do any of that. But you get the idea. We can override it, and we can also have a base. This is the default implementation. Animal speak, and which when we're creating a dog and we inherit from animal, then we get a dog barks. But like abstract methods, you can still override it, as we can see. Okay, virtual methods are powerful. They enable runtime polymorphism. The method calls the method call is resolved at runtime based on the actual object type. Virtual methods are great for extensibility, making them great for things like framework, libraries, packages, those libraries you would download from NuGet and so on and so forth. But there are limitations. You cannot use virtual with static. So if we have, if this was static, okay, you see, it says cannot declare instance method in a static class. So that's a limitation. Okay. um, and you cannot use private methods as well. Constructors or methods already constructors or methods are already marked as abstract in virtual. So next up, let's talk about uh, partial methods. Okay, this should be the last one for types of methods. Um, Partial methods in C Sharp allows you to split the definition of methods into two parts: a declaration or signature in one partial method and an optional implementation in another partial class. Okay? Um, so we say class my partial class, partial void on something happened, just string s, something happened, um, and we say this as, this is of course partial. Okay, that's why we had an error. And then we can say here we just, all we did here was we just declared the definition. That's all we did. On another one, we say partial class, my partial class. Okay? Another one, and we say um on something happened. Now we get to implement it, and it says console.write line uh, something happened. Now we can say s. Okay, let's say you whatever something happened s, just like that. If you comment out one of these methods, if you comment out one of these methods, okay, it would still run. Oh, actually, we would need. Okay, you see what I did there? If you comment this out, it would still run. Okay. For example, you cannot use partial keyword on static constructors. The partial method must return void. Okay, void right here. You cannot return anything but void. It doesn't have any out parameters. You cannot use virtual. You cannot override it. It's sealed modifiers either. You can't use sealed modifiers either. Oh, this method is mostly used when the compiler is generating code. That's why it's so weird. Okay, so you know maybe don't worry about it too much, but it's important that you know know it's there. Okay. So we're done with types of methods. Okay, um, let's talk about local functions. Let's talk about local functions. Um, Local functions are features that allow you to declare methods inside other methods. So we have public, static, class, area. Okay, and we say public, static, double, calculate, circle, area. Just go with it. It's radius, and then we say static double square um, double value. Now remember that the area of a circle is uh, pi uh, r um, squared, right? So maybe we want to calculate the squared first. Return value times value, okay? And we can see maybe we want to calculate the r squared, because usually it's, it would be in a bracket like this. If you know how to do math, if you're good at math, you know what this is. um, the order in which you calculate things. And then we can say return math dot pi times square radius. And this is it. Okay, so when we're creating this object called um, this static object called area, and we want to calculate the area of a circle. Okay, well, the area of a circle is pi r squared. So we may not want to just do it in one go. We can't just do it in one go. First, we need to calculate r squared. Okay, radius times radius. And so we create a method inside another method. And the method to double the square, which is to square the radius, is any number times itself is the square of that number. And then finally we can return, and this returns a double, of course. And so by the time we do pi r squared, we now have r. So now we have return pi times squared r. And so this is what I was talking about when I say local functions. Local functions are methods. This is a method, see, inside a much larger method. Hopefully that wasn't confusing to any of you. So local functions help with encapsulation, keeping the helper function squared private. Okay, so this you cannot you cannot call this outside of this method, and there's no reason to do that either. Okay, keeping the helper function squared private and only accessible to the method where it's needed, which is this. Okay, readability. Obviously, keeping this, the next important thing is readability. Keeping these two methods together makes things much clearer and cleaner for anyone. Like, if you look at this, you can pretty much understand what's going on here. Okay? But be careful though, they can only be called from within their containing members. So it can't go past this. And that's of course a good thing. Okay? Local functions cannot have cannot have member access modifier. So private, public, or whatever. You can't do uh, you can't say private or whatever like this. It will not accept it. You can't use internal or protected, any of that. It will only, so you cannot put an access modifier. Okay. They can only be called from within their containing members. So, which is, this can only be called by this. And that's a good thing, like I said. All right. Let's talk about method overloading. Method overloading is the ability to define multiple methods with the same name but different parameter lists. So let's deliberately create an error here. Let's say public class calculator, okay? Um, and we say public int add. And in here we have int a, int b. And then we say return a plus b. Simple enough. Now, like I said, we're going to create a deliberate error here. Let's create that exact same method twice. And so we can see that we have an error. It says type calculator already defines a method called add with the same parameter types. Now it's important to know that this a doesn't matter. It could be x and y, and it would still give us that same error because it's not really about this a b. These are arbitrary things that we put in that programming language creates to help actual human beings read and make sense of what they're coding. Okay, but the compiler doesn't. This C sharp and any program actually wouldn't look at this AB. They would look at this integer. There are two. First of all, there are only two parameters: the name and the parameter types, and the parameter numbers are the same, which means in the eye of C sharp, these two things are the same, and you can't have that. So how do we successfully create method overload? Well, what if we add int c? So now we have c. And now it's gone. The error is gone. We have successfully created a method overload. If we have, first of all, different number of parameters. So these are two parameters and these are three parameters. So this is acceptable. Or if we have different types of parameters. So let's put this back the way it was. What if we change this to rather than double, rather than rather than an integer, we turn this into double. Okay, which means of course the return type has to be double as well. So now even though we have the same amount of parameters, 2, it's acceptable because the type of parameters are different. These are integers and these are double. 32-bit integers, 64-bit double. Okay? So keep that in mind. Number of parameters first, types of parameters second, and finally order of the parameters. So you know what, in order to do the order of parameter, let's use a different public class person. And we say public void add person. Okay, string name int age. Let's turn this. You should make it a habit to put it capital. Console write line, and we say name is, why is that? Oh, right. Age, years old. All right, let's do the same thing here. But now let's change the order of the parameters. So int age string name. And we say age is names age. All right. So we see that it accepts it. So once again, there are three types. There are three ways you can overload. First is the number of parameters. If the number of parameters are different, that's a successful method overload. The second is type of parameters. If the types of parameters are different, then that's acceptable. And third is the order of the parameters, which is this case. We have the same name, but the order string name first and int age. Now we have int age first and string name, and we see that they both work. There is no error here. Now the compiler is actually is smart enough to determine which method is to be called based on your inputs. So, oh man, I probably shouldn't have deleted all that. Let me just go ahead and do that real quick. Let's go ahead and create a class calculator public int add int a, int b, and we say return a plus b. Let's go ahead and do this. Int c. All right, and then this is going to be double A, double B, double C. No, just 2. Okay, so now the compiler is actually smart enough to determine which method is to be called based on your input. So let's go ahead and say variable calc equals new calculator. Okay, so we're calling in this, and if we say console dot write line calc dot add 5 plus 5, and if we say console dot write line calc dot add 5 plus 10 plus 3, doesn't really matter. Console dot write line calc dot add 1.5 and 0.4. Okay, and let's go ahead and say the next line, variable person. Well, you know what, let's just go ahead and do the calculators first. And here we see, let's go ahead and say .NET. First, let's build this huge convoluted stuff. Okay, it built successfully. Let's clear the screen and say .NET run, and we get it. You see, the first one is calc.add with the 2 parameters, and we can see it calls on this one integers with 2 parameters. And of course, 5 plus 5 here is 10. And when we put three parameters and it says 5 plus 10 plus 3, it chooses this method with three parameters, which is 18. And when we used fractions, 1.5 and 0.4, it chooses this one with doubles and it gives us 1.9. Correct. And so that's what I was saying. The compiler is smart enough to determine which method is to be called based on your inputs. Okay. Um, let's go ahead and do the person one. Person equals new person dot add person Daniel. Daniel is 40 years old. And let's do person dot add person 32 Linda. Okay. Let's clear the screen and say .NET's run. You see, Daniel is 40 years old. 32 is Linda's age. When we put in the string first, it's smart enough to pick this one, the first add person. And when we put in the integer second, integer first, it's smart enough to pick this one. And so that's what method overloading is. So remember, the rules to method overloading is one, you must have either different one, number of parameters, two, types of parameters, three, order of parameters. So why do we need method overloading? Well, simple. It allows intuitive method names for similar operations. Adding two integers and two doubles are similar operations. Okay? Look, two integers and two doubles. You just add two numbers together. Which brings me to my next reason, which is support for different types of inputs. Okay, so you can support different input types and combination. Ultimately, you're reducing the need for multiple method names that do the exact same thing. Because one, we can say add double, for example, or add fractions. Okay, you can do that if you want, if we had to, but why not leave it that way and then use different, so you can just call it based on what you need. You understand what I'm saying? Okay, so you're reducing the need for multiple method names that do the exact same thing. In the end, method overloading is simply about one thing: readability. Readability. And finally, let's talk about extension methods. Okay? Extension, final topic is of course extension method. Extension methods allow you to add methods to existing types without one modifying, let's go ahead and delete this, without modifying without modifying the original type, and two, inheriting from the original type. You don't have to inherit. Or three is recompiling. They are very useful for extending sealed classes, interfaces, or even third-party libraries, packages from, NuGet, if you want to download a package. If you're new, if you're new here, the sealed keyword, if you're new to C Sharp, the sealed keyword is a modifier that restricts inheritance and overriding of classes and their members. So if I put this like this, public sealed class, okay, and I inherited like this. Oh, right. And I tried to, say inherited class cannot inherit from sealed class. And I say something like this: public sealed class, uh, inherit inherited class, and I try to inherit from this, we're gonna get an error, and hopefully it matches with this. It says inherited class cannot derive from sealed class, and that's the beauty of it. If you want to seal a class so that no one can inherit from this is all about, again, you know, encapsulation in programming. So, anyways, extension method is a way to get around this. Okay, it's a way to get around sealed classes and also existing libraries. Now, what are the steps to create an extension methods? This is very important. Listen closely. First of all, to create an extension method, the number one most important thing is that you must have number one is that static, the method and the class that is within the method within the class and the class itself must be static. So you have static class and static methods are a must. So let's go ahead and do that. Public static class date time. All right, let's do date time extensions. Okay, so this is a class. So the class must be static, but also the method must be static. And so we say public static. How can we extend date time? Okay, yeah. Let's say bool is weekend. So it must both the class and the method must be static. Secondly, second, the first parameter in this method must use the this keyword. So we say what we're trying to extend is datetime. This space date time date. Okay. This points to the type being extended. This date time. This is what we're trying to. You see, this is date time extension. We're trying to extend the date time, which is of course a which is an actual type date type in C sharp. In all programming languages, that's how you keep the time. All right. So rule number 3 is that, well, I won't be showing you in this. I won't be showing this to you because you have to import the name. But since we're doing all of this in one under program.cs, then you don't need to but if we created this in a different file, let's say in an actual project, this is just a simple console application the uh, uh, for the purpose of teaching C sharp. But in an actual project, then we would have to using namespace, we would have to import the namespace that it's using. Okay, so that's the third rule. You see, must import the namespace. containing the static class. But we're not gonna use this here. But anyways, let's go ahead and do this, and we say return date dot day of the week equal day of the week dot Saturday or let's go ahead and do it like this: dates dot day of the week equal day of the week dot Sunday. You hopefully you know enough about programming to know what this means. So static bool is weekend. So return if this bool will be true if the day of the week is either Saturday or Sunday, which of course means weekend. All right, so let's go ahead and come up here and say date time today equals date time dot today. Okay, now we say bool is it weekend equals today, which is pointing to this today that we created. This today object is, and here we can see when we click this, we can see all the method attached to date time, which is of course primitive type. Add day, add hour, add microseconds, add millisecond, add minutes, add months, add seconds, add ticks. Okay, date, day of the week, and as we go down and go down, we see get type. These are all inbuilt methods associated with date time. But check this out. Check this out. It's weekend. It's weekend. This is an extension type that we just created, and now the compiler recognizes, C# compiler recognizes this as an extension method. This is not built in. It's weekend. It did not come with C#. We created this just now, and the compiler recognizes that and puts it in it, and so we can say it's weekend. We've just called a method on a class, a method on an object that wasn't there. It's not inbuilt, and that is amazing. We've called it in a way that makes it look like right line. That makes it look like this is actually inbuilt, and so C# is very, very flexible and extendable. So let's find out. This bool is going to be true if it's weekend and false if it's not weekend. So let's go ahead and .NET run, and it says false. And that is of course because today is Monday the 28th. July, Monday the 28th. So obviously it's false. It is not a weekend. This is correct. It is not Saturday and it is not Sunday. So therefore this is false. I'm sure you can imagine how useful this would be in a real world application. Well, that we've covered C# methods, functions, if you like to call it that. And that's all we have. That's all I have today. If you liked the video, please like and click the like button, click the subscribe and the bell icon to get more videos. Of course, more videos are coming in. I appreciate if you made it this far. This video is at least over an hour, over probably an hour and a half long. Anyway, I wasn't keeping track, but That's all the time we have. Thank you. Thank you so much for watching this video. I really, really appreciate it.